My name's Craig Roach. I'm a solution architect from the Wellington office. I'm in the public sector team, and today we'll be talking about building serverless ETL pipelines with AWS Glue. Now, I haven't worked for AWS for my entire life. That won't come as a surprise to you, but before I joined AWS, I worked for a bunch of public sector agencies, and part of my day job there was to actually build ETL pipelines. And I've worked in roles like developing the code, provisioning the infrastructure to run the pipelines, to actually fix the pipelines when they break, architecting the pipelines. So I've got some sort of personal experience with what the challenges involved in ETL tasks actually are. And what I'd like to do today is actually ask you to put yourself in the shoes of someone who's actually been given that job of actually marrying up the disparate and diverse set of data sources that we need to deal with in most enterprises, and actually servicing the needs of data analysts and data scientists on the other end of the street, on the other end of the pipeline. And your task as this ETL expert is to, I guess, abstract away all the gnarly and arcane and obscure details involved in translating and transforming data from one format to another, so that your end consumers, those data scientists and data analysts, are blissfully unaware of all the hijinks and gymnastics you've had to do along the process. So what I'd like to do is just start with a typical flow of what a modern ETL pipeline would look like running on AWS. So the first thing is generation. Sorry. First thing is generating the data sources. Now, the typical sort of generators of data sources in enterprises are things like transactional legacy systems, ERP systems, things like SAP. More and more we're seeing things like weblogs capturing information about the citizens and the consumers that are actually hitting the websites. If you work in the utility space, you might be seeing some more sensor networks that are feeding data into the data pipelines. The next part of the system is the collection side, and you might see services like, you might see polling services running on EC2, going out to the enterprise systems and pulling data or file shares or from databases. A modern system might be dealing with using technologies like Amazon Firehose to pull in real-time data, Kinesis streams. You might also see things like AWS DMS. So if you're doing things like database replication, replicating a source database running on premises to a target database running on AWS, you might see that as well. You'll just about always see Amazon S3, so it's a very versatile service. A lot of customers that I'm working with are syncing data from their on-premises systems into S3 buckets on a regular basis, pushing that data to AWS. And you might also see snowballs where they're available. So you can use snowballs to do bulk transfers of data. So that's on the collection side, and on the storage side, it's a fairly traditional picture as well. S3 figures large as a storage medium for bulk data. As you'll see later in the story, it figures large in the actual ETL process as well. You'll see services like Amazon RDS, various flavors of engines running within RDS, and you'll see customers running their own databases on EC2 as well. So that's your storage layer. I'm going to skip over the extract and transform layer because that's going to be the exciting part of the presentation, and I'm going to go to the analyze layer. Now, the sort of services you might see in the analyze layer are things like Amazon Athena, which acts as a query engine against data. You might see Amazon EMR. So a lot of my customers are running things like Spark clusters on top of EMR to run things like R functions across large data sets using frames. Some customers might be running Redshift and Redshift Spectrum as well, and some might be running Kinesis Analytics when they're dealing with real-time data. And then lastly, we've got the end consumers of our pipeline, the data scientists and data analysts. The data scientists will be happily ensconced in their RStudio environments working with data frames running in Spark. You might have data analysts who are doing things like running Tableau or QuickSight to do queries, SQL-oriented queries. You might have business users that are running things like dashboards against the data as well. So there's a variety of applications, variety of visualization tools that end users can use. Now, I promised to go back to ETL, and what's actually an ETL are services like EMR and Lambda and Amazon Kinesis. So that's pretty much the state of play at the moment as far as ETL technology goes. You might be wondering, so what's wrong with that? Where's the problem? Well, I've got a solution stack. It looks okay. It's all cloud-based. The challenge associated with using those tools in that ETL stage is actually the volumes of data that they're dealing with. Some of my customers have seen situations where their data growth or data requirements and storage requirements have gone from a linear function to an exponential function. They're talking about how many years does it take for their data volumes to double. And that's been driven by things like increasing time resolution of data, increasing sources of data, things like web analytics feeding into their data warehouse, more ways of engaging with citizens, generating massive amounts of data. The other thing that's driving this is the need to, or that's complicating this, is the need to incorporate disparate data sets. You've got data sets that are coming from the general ecosystem, not just from the agency's internal systems. So you've got communities of services that are trying to feed into a single data lake. You've also got things like vendor systems, vendor formats that are changing and driving the need to perform ETL processes. And organisations don't stand still either. So some of my customers have actually got a current system and what they call a heritage system, which is a system that hasn't actually been shut down, but it's been kept there in case they need to run forensic analysis or some sort of machine learning job in future. So there's multiple generations of systems floating around. They're all generating data, oftentimes in different formats. And the challenge that ETL has is to actually synthesize all of these in a unified way. And then lastly, you might have been to some presentations today talking about machine learning. So that need to have highly refined training sets for doing machine learning is also a driver. Now, I asked you to have a look at, to think about the problem from an ETL software developer's perspective. And what I'd like to share with you is what I often find when a business analyst would tell me, hey, we've got this new data set from agency X or from this international body, and we'd like you to start incorporating in our data warehouse. By the way, it's sitting on this file share or it's sitting in S3. And that's pretty much what you're going to see, just an obscure bunch of directories. And you think, great, how am I going to make sense of this? Well, what I'll do is I'll step into one of those directories and have a look and bring it up in an editor and see what it is. So you open up a directory. Oh my God, more directories, more obscurely named directories. What do you do then? So you persist, you keep on drilling down through the hierarchies. Finally, you get to a piece of something you can read. And obviously, this is a piece of JSON. But then the question that might pop into your mind is, well, I've done a random sampling in my data. How can I know that this is actually the consistent schema that's being applied throughout the entire data set? Because potentially we're talking about terabytes of data. So this is sort of the problems that ETL engineers are actually facing on a regular basis. It's not the end of the story. Well, I mentioned data volumes, the growth of data volumes and additional data sources. But the other challenge is that these data sources and the mappings from these data sources to the target formats are almost unique to every organisation. And whenever you have uniqueness, that inevitably means there's a human involved in writing code to manage that diversity. So managing all those variations in hand coding is a challenge. The formats change over time. So as I mentioned, that the organisations evolve, the data sources evolve. Excuse me, I'm just going to grab some water there. So how do you actually deal with these changes over time as well, and even recognise that the changes have happened proactively rather than waiting for your ETL pipeline to break? So what the consequence of this is that ETL assumes a much larger footprint in your organisation than it really deserves. Ultimately, it's a piece of plumbing. It's a little bit like the aviation security queue that you have to go through on your way to your holiday in Tahiti. It should just be a minor part, a necessary part, but it's not the reason you're taking the trip. But in a lot of organisations, there's a whole culture, a whole team that builds up around ETL. And really the focus where you want to be is on the rewarding part, the analysis and consumption of that data. So the challenge that we're trying to solve is how to actually shrink that ETL process down so it's less of a burden for organisations to deal with. And this is where we come into Glue. So what I've done is I've suggested here that AWS Glue is potentially the one tool you need to use for most of your ETL requirements. Okay, so what's the benefit of Glue? What's its secret sauce that makes it so powerful? The first thing is that it has the ability to automatically discover and catalog your data. So it can scan your data and put it into a Hive-compatible metadata schema. If you've been to some of the other big data presentations, you would have heard that Hive-compatible metadata schema mentioned many times because it's the engine that drives things like Athena, Redshift Spectrum. It's the piece of information that those query engines need to operate. So Glue will actually generate that data catalog for you. The other thing is that once it's catalogued, it makes that data immediately queryable by services like Athena and Redshift Spectrum and EMR, so they can leverage that catalogue to actually run queries directly on the data while it's sitting on S3. There's no need to actually load it up into a relational database or an OLAP type database. You can run the queries in place directly against that data, and that catalogue is that secret piece of information it needs. The other thing that Glue does is it generates the code for you, or at least generates the first iteration of the code for you. So it will generate your ETL code. It will clean your code. It will generate cleaning logic for you, enrichment logic for you, mapping logic, and choice resolution logic for you. The data is adaptable, so once it's actually been generated by the mapping tool, you can actually go and edit that, and in a lot of cases, customers will, with sophisticated requirements, will use the generators just to produce the first iteration and then take it from there. They'll get it to do the donkey work, and then they'll code it themselves from that point on. And the other thing is that Glue doesn't generate code in obscure language or any proprietary schemas. It's actually just using PySpark or Scala when it's actually generating the code. So that means portability. If you decide that you want to take your PySpark code and run it in a off cloud or on a different cloud, then you can do that. You can actually take this source code, it's been checked into GitHub, and you can run that code in your choice of environment. That's quite important to some of my customers in New Zealand at least. And it runs the job serverless, so that's a really powerful feature of Glue, because I mentioned that as an ETL developer, your job was thinking about schemas, but oftentimes your job as an ETL developer was actually thinking about infrastructure as well, worrying about how fast your SAN is, how many IOPS you can generate out of your SAN. When you're dealing with this and making sure you've got the right operating system versions, when you're running serverless, that problem sort of disappears, because what's happening is the jobs are running within an AWS managed cluster for you. So you're not having to worry about provisioning all that infrastructure. And we'll talk a little bit later about how that world between the AWS managed cluster and your particular data resources is bridged. But just suffice to say at the moment that AWS is taking care of provisioning the resources to run those ETL jobs for you. And lastly, Glue gives you the ability to schedule and trigger your jobs. So you can do the classic sort of time cron-based scheduling, but you can also set up quite complex dependency chains where the completion of jobs triggers subsequent jobs. You can have or conditions or and conditions that say, once this job A and job B completed, then I can start job C. So there's a lot of flexibility there as well. Now, I'm going to move fairly quickly through some of the slides that show screenshots of Glue, because rather than getting you to squint your eyes at fairly hard to read screenshots, I'm going to actually show you a live demonstration where I'm going to do some Glue jobs for you, so you'll see much more interactively what it looks like. So just going back to the theory though, how do I ETL my data? So the typical flow is 4 steps. Now in practice, we describe it as 4 steps. In practice in most organisations, there's a fair bit of iteration and experimentation that goes on. But for now, we'll just say there's 4 steps that are completed sequentially. The first step is crawling. And crawling is actually the process of discovering what the schema is in your data. And it really is a simple matter of actually pointing Glue at a data, an S3 bucket or a database schema, a database running on RDS, for example, and telling it to find out what is the schema behind this. And then Glue will launch the crawler and actually discover that schema and publish it into the metadata catalog. The next stage is mapping. I'll just put that there. So mapping is the process of taking your source schema, the discovered schema, to your target schema. So as an ETL designer, you'll have some schema in mind that you want to map to. So you're going from a source schema to a target schema. And that mapping process can be as simple as just renaming a few fields, doing a few type conversions, to a much more sophisticated restructuring of the data, doing things like relationalizing data that isn't relational by its nature. And we'll touch on that a little bit during the demonstration. You can then edit and explore the data. So once you've actually done a mapping, you can decide to actually do further. You can run query tools directly against it. You can start running Athena against it, running queries to discover more about the actual structure of the data. And you can iterate on that process. So you can build together chains of ETL processes to reach your target state. And then lastly, you can actually schedule these jobs. So once you've gone past the on-demand experimentation type of process and you're ready for things to actually go into production status, then you can start setting up schedules to run these things on a regular basis to reflect the timeline under which the source data sets are being changed. So let's go through those 4 steps one by one, just quickly. But I'll just highlight some of the theory involved just so that you're prepared when we get into the demo. So first of all, crawlers. Now, crawlers are mentioned there to automatically discover your data. And one of the key elements of the key value adds with Glue is it has a whole library of built-in classifiers. And those classifiers will understand common formats, and we'll see those on the next slide. But you can also write your own classifiers. So if you've got some decades-old data format that was invented by someone who's long since retired, and it was designed for human readability and not so much for automatic processing, you can actually write custom classifiers to help parse that using tools like regular expressions. And you can build those into your pipeline automatically if you need to. So I mentioned that there are some of the major data classifiers that the crawlers will work with. The first thing to note is that the crawlers can either use JDBC connections as their source, so that opens it up to things like any of the Amazon RDS databases. It opens it up to Redshift. It also opens up, which isn't on the slide here, but it also opens up to the possibility of querying databases managed by the customers running on EC2 or even on premises. Crawlers can also deal with object connections, and these are just pointers to S3 buckets. And then the crawlers will go away and recurse down through the bucket structure, through the folder structure, and discover what's actually underneath. The classifiers that are built in are things for there's built-in classifiers for all the open source databases that can query their data dictionaries to discover the underlying tables. And there's also support for common open source compression formats, columnar compression formats like Parquet, Avro, and Awk. Obviously works with JSON. It supports a number of compression types, gzip type compression types and variations on that, and regular old CSV, where we'd be without CSV, and then obviously supports custom grok expressions. That's what a classifier looks like. I'm not going to belabor the syntax here, but suffice to, sorry, I'm pointing my laser at the human there. The grok expressions are more or less just the generalization of regular expressions. So anyone that knows regular expressions will be fairly up to speed with writing their own grok expressions. There's also built-in expressions for things like common timestamp formats. So if your timestamps aren't in the ISO standard format, you can write your own, use a building block to build up your own timestamp parsers. And there's a little example on the slide there of crawling an Apache weblog. So things like log levels, meshes, prefixes. The other thing that crawlers can do is to detect partitions, and partitions are a really powerful feature of when you organise your data on S3. And what I mean by partitions is the really common pattern, for example, is to organise your S3-based data into folder structures that are organised into years, months, and days. And that gives you a very convenient way of organising your data, but also applying a lifecycle policy so that older data ages out or moves down to other storage formats. So what Glue is able to do is recurse through those folder structures and actually use a heuristic to discover, ask questions like, is that folder actually a year? Am I seeing that same year repeated over and over again? And can I reliably infer that folder name that says year equals 2018 is actually an attribute of the underlying data that says that this data is actually one of the year attribute for my underlying data is 2018. Likewise with the month and the year and the day components underneath. So what ends up happening is that Glue can infer that that folder structure is actually not just a bit of decoration and housekeeping. It's actually an integral part of the data itself, and that will extend the schema that it discovers with that folder structure. And on the slide there, you'll see a little example there with months and days. Excuse me. I'll step through these quickly so you'll see those in the demo with the Glue data catalog and the table properties. Very hard to read there, and you'll see a live one in a moment anyway. But the table properties bring up stable statistics, the columns that it's discovered, and the data formats of those columns. So how do I build the ETL? So the first, the Glue will actually guide you through the ETL process. It will generate the code for you through a job authoring tool. It will let you graphically manipulate the mappings. It generates code for you, and you can actually see a little bit of code there. You'll see it in the demo in a moment. It's quite readable. It's actually got documentation within it. The functions are relatively clear. It's declarative. There's not many conditions. There's no loops or conditions in there. Now, one piece of theory I will mention is that Glue uses the concept of dynamic frames. And dynamic frames is a way of actually dealing with surprises in your data. Because you realise that once you've actually catalogued your data, there's no guarantee it's not going to change. Data sources change all the time unexpectedly. So what dynamic frames let you do is set a policy for how to deal with those surprises. So those surprises could be, for example, that the data type suddenly changes from an integer to a string. So you can set dynamic frames are able to keep track of those changes at a row level and actually set a policy for whether it should cast the data from the source to the target, whether it should null it out or whether it should drop it out of the mapping altogether. The key piece of functionality in Glue that lets you do that is a function called resolve choice. And resolve choice will let you take these variations in the data and actually decide to actually do that mapping or the cast operation, or in fact even split it into two separate columns. So you can leave it as a task for the downstream process to deal with the fact that there's actually a string representation of value and an integer version of the data floating around, so that so you're not losing data during the mapping process. There's also the apply mapping function, which is the function that does the renaming, flattens out structures, nested structures, does the actual reordering and type conversions of data. And there's quite a magical function called relationalize, which will actually take nested arrays and flatten them out into a relational model. So it will actually build secondary tables for you, build the foreign key relationships for you, so you can take nested arrays within structures and turn it into a relational model that your relational query tools can happily deal with. And there's some ETL code there. I'm just going to quick moving so we don't run out of time. Developer endpoints, because you're running Glue in a cluster that's provisioned on demand, you might be wondering, so as a developer, how do I actually interact with this? How do I actually run my Zeppelin notebook against Glue when the cluster comes and goes based on jobs? And the answer is that we'll provision endpoints for you to point your notebooks at, so that you can run that sort of coding, expression, evaluation, print type loops interactively. And lastly, all the code associated with Glue itself, the libraries that make up Glue, are published in GitHub. There's also sample code published in GitHub, and you can actually use GitHub to share the code that you develop. I'm just going to run quickly through the execution mechanism. I mentioned that Glue creates a bridge between your VPCs and your compute instances. And the way it does that is by dropping an elastic network interface into your VPC. So as far as your VPC is concerned, Glue is actually sitting as a network interface within your VPC, which means it can talk to your databases, it can talk to your on-premises systems over Direct Connect. It gives it access to S3 endpoints. So it means that you've got that happy mix between a serverless environment and access to VPC-based resources. I'll skip over the pricing unit, but it's not really relevant to the demonstration. But the DPUs are the unit of cost, because you're not actually provisioning an instance type. A DPU is a measurement of resource provisioning. So you set a cap on the number of DPUs, which is a 4 VPCUs and 4 vCPUs and 16 gigabytes of RAM. You say that's the cap I'm prepared to run with, and I'm going to actually execute my job up to that cap. When the job actually runs, the bill that you get is actually based on the amount of resource you consume, the DPUs you consume, and they're consumed on a per second basis. There is a 10-minute limit, lower limit, but you're only billed for what you consume. So there's not like a standard EMR cluster where you're actually choosing instance types and the number of instances. There's also costs associated with the metadata catalog itself, but the free limits are actually so high that I've never seen a customer actually get a bill for their schema objects. So they're quite generous in that regard. And I think I've mentioned job composition already, so that's the mechanism by which you can chain together glue jobs to create a sequence of a dependency chain. So let me switch over to the demo at this point and show you what it looks like in practice. Let me switch over. Okay, thanks. So the scenario I want to paint is that we've got a business analyst who's come to me as an ETL developer and said, I want you to produce a graph like this. Sorry. I want you to produce this graph for me. And the example is that it's ground transportation statistics in the city of New York. And what I've been asked to do is produce a day-by-day breakdown for a particular month, showing what are the various transport providers or the number of trips provided by different transport providers in New York for that month. And there's actually 3 separate transport providers that have been feeding us data. There's yellow cabs, green shuttles, and Ubers. And what you're actually tasked with as an ETL analyst is the job of actually discovering what that data looks like. So the BA has told you that you just go and have a look in S3 and see what's actually being pushed into S3. So we have a look at the console. Okay for size. And I've got a bucket here. And I've got a folder here that's got 2 subfolders in it, green and yellow. And so they're obviously the names of the cab companies. Green shuttles and yellow data. If I have a look in yellow, let's have a look at what's in there. So it's a whole bunch of obscurely named files. So if I open one of those and have a look at it, this is what I might see. So good old JSON. The question is, what's the schema that's being used in this? There's actually 25 million records in this bucket. What is that schema? So what I'll do is I can use Glue to help to come to the rescue. Sorry, just get my... And I'm going to write a crawler. So I say add crawler. And call it yellow crawler. I'm going to use S3 as my data source, and I'm going to point it at this bucket that I just had a look at. So I'm pointing at the yellow folder. So it'll ask me if I want other data stores. That's enough. Now it's going to ask me about a policy, an IAM role to run, and that's an important security aspect of Glue. I'm going to point it at an existing role, and this role has the permissions that tells this Glue job it's allowed to read that bucket. So it's going to perform a series of get object operations on that data. I need to make sure it's authorized to do that. Then I choose run on demand, and I just choose the database I want to drop the actual discovered schema into. And at that point, I could actually run the job. Now, I'm not going to do that because it takes about a minute or so for a crawler to actually execute. But I'll show you what it would produce as an output. So I go into the tables section, and I'm filtering this list of tables by the database name, which is Summit 18. And this entry down here called yellow is the name of and you'll see the location there matches our discovered, the folder we're pointing at. This page here shows what the discovered schema is. So it's discovered all these attributes of our data. And you'll see down the bottom here, there's all the usual data types like int and string, but there's a structure here called fair info. And if I click on the struct tab there, you'll see that the fair schema details have actually popped up. So it's actually drilled down into the substructures as well. So now I've discovered that data. That's just one of my providers. That's the yellow cabs. Now, the next thing I need to do is think about the other 2 providers, Uber and Green. Now, I haven't got time to actually build a crawler for those, but Green cabs, for example, in this example, is actually a CSV data set. Uber's actually in a database. It's in an Aurora database. So what I'm going to do is actually try and build an ETL job that's going to pull together all those data sets into one single unified data table that I can then point my query at. So So I think I'm just about out of time here. So let me just show you what the actual target table looks like. So I'm going to go into Athena. And when as an ETL designer, what I would do is actually create the target table format in Athena, and I've called it ground trips. And if you just have a look at there, that's the actual schema on the left-hand side here that I've designed as an ETL designer. Now, having designed that, what I've done here is I've put the provider as an attribute of that actual ground trips table. So that allows me to unify all of my sources into a single source. Now, excuse me. The other thing it's done is, standardize the date time attribute, which is because it's a time series, it's really important that I can do that. So I'll just show you one other aspect of Glue. Let's go back to Glue, and then to write the actual ETL job, it really is as simple as going into jobs and saying add job, giving it a name, choosing the role, so it's going to be writing into an S3 bucket as well as reading one, so that role needs to have permission to do that. I'm going to ask it to propose a script for me, so it's going to generate the code for me. Go on to the next tab. Let's make that a little bit smaller. And then I'm going to get it to choose a data source. Oh, that's quite a bit crazy there. There we go. And I'm going to tell it to look at the yellow data set, and then the data target, I'm going to tell it to use the ground trips schema that I've defined in Athena as my target. And then it pops up this mapping page that I showed you earlier, and this gives you the opportunity to take the source columns and actually map them to rename them and change the data types in the target columns and actually flatten out structures. So here you've got a fair info structure. I can pull out sub-attributes of that and put that into the target schema. So at that point, it's going to propose a set of code for me, and that's the actual ETL job itself. So it's quite readable PySpark, and on the left-hand side, it will generate a diagram showing me what all the transforms involved in running the job are. Now, I'm not going to run the job now. It takes about 8 minutes on our 25 million records. It's reasonably quick. But the end result is, if I just jump back to Athena, is we can have a look at some of the actual ETL data. I've got this ground trips yellow view defined in Athena, and it's running the query now. So that's actually querying the ETL data, and you can see it's actually provided moved the yellow data, tagged in the yellow provider, mapped the date times, and it's converted over the trip distance and fares. Now, once that data's in that format, it opens up a whole lot of possibilities with by running in terms of views I can build on that data. So this is regular old SQL expressions at this point. And if I run this query here, you can see I've got a view here that shows some really interesting statistics about these providers. For the yellow cab company, the average distance of a trip, the average cost per mile, the average fare, and the 95th percentile fare. So you get some idea about what's the maximum you'd be likely to pay. So it's a very powerful engine that's actually running interactively. There's no optimizations here, interactively against millions of records sitting just in S3. So just to wrap up, what we've done with this demonstration is shown how with Glue you can discover data sitting in a variety of sources, S3 buckets, CSV, JSON, Aurora databases, produce a target schema matching what your analysts want to see, and divide an ETL job to map from those source data sets into a unified data set, which you can then run traditional SQL queries and your choice of visualization tool against. So thanks very much. If you could just fill in your feedback cards on the way out and just swipe on the exit. Thanks very much, everyone.